Finding these sums and differences, the only thing we have to be careful of is just removing the parentheses. So this would be 4 plus 5i plus 6 minus 3i, or 10 plus 2i would be my solution. Here, when we remove the parentheses, we'll have 7 minus 3i. And remember, this is a negative 1 times each of these things. So negative 1 times 5 is negative 5, and negative 1 times positive 2i is negative 2i. Now we can combine like terms. 7 minus 5 is 2, and negative 3 and negative 3i and negative 2i will give me negative 5i will be my solution. When we find the product of complex numbers, we must remember FOIL. Remember, that means the first term, the outside terms, the inside terms, and the last terms, just as if we had two binomials to multiply together. So first terms, 3 times 3 is 9. Outside terms, 3 times negative 4i will be negative 12i. Inside terms, 2i times 3 would be plus 6i. And last terms, 2i times negative 4i will be negative 8i squared. Combining like terms, 9 minus 6i. And remember, this i squared is negative 1, so this will be plus 8. And my final answer will be 17 minus 6i. 9 plus 8 is 17. When we're squaring, just as if squaring binomials, square the first term is 25. You might remember when we're squaring binomials, when we do the outside and inside terms, they're the same. So I can take 2i times 5. It's negative 10i, and because we'd have two of those, it'd double it, so it'll be negative 20i. And the square of the last term, negative 2i times negative 2i, will be positive 4i squared. The I squared is negative 1. So 25 minus 4, or 21 minus 20i, will be my product. And using FOIL again, 3 times 3 is 9. Outside terms will give me plus 15i. Inside terms will give me negative 15i, and the last terms will give me negative 25i squared. I squared again is negative 1, so this becomes positive 25. Oh, 15i and negative 15i, that's 0, plus a 9, or I'm just going to end up with 34 as my solution. May remember, this looks like is the factors for a difference of squares, and that's really what I do have. Let's simplify this. Well, use our definition here first. We'll have negative 10 plus I times the square root of 75 over 5. Square root of 75 does have a perfect square factor, 25 times 3. So the square root of 25 is 5. This will lead to negative 10 plus 5i times the square root of 3 all over 5. Oh, wait a minute. 5 is a factor of this numerator. It could be 5 times negative 2 plus I times the square root of 3 over 5. Now I have 5 as a factor of both the numerator and denominator, so those can factor out, and my solution becomes negative 2 plus I times the square root of 3. This looks very similar to that 3 plus 5i and 3 minus 5i we did, and they say that it equals a squared plus b squared. Let's see if that really works. First terms will give me a squared. Outside terms, negative abi. Inside terms will give me positive abi. And the last terms will give me negative b squared times I squared. But I squared is negative 1, so that becomes plus b squared. Ooh, negative a plus bi, negative abi plus positive abi, those are gone. A squared plus b squared. So that proves it does work. And we will need complex conjugates will become very important. We divide these, and we want to write these in standard form. Now we have to remember what I actually means. We have 4 plus 3 times the square root of negative 1 over 7 minus the square root of negative 1. That means we have a radical in the denominator, and we need to rationalize that denominator. And here's where our complex conjugates come into, because we can use those to get rid of this radical. So we'll take 4 plus 3i over 7 minus I. If we multiply the denominator by 7 plus I, that will get rid of our I terms. But remember, if we're multiplying the denominator by something, to keep it equal, we have to multiply the numerator by the same thing. So using FOIL for the numerator, we'll get 28 plus 4i plus 21i, so plus 25i, and 3i times I, we positive 3i squared, or negative 3. So for the numerator, right now, I have 25 plus 25i. Oops. Yes, 28 minus 3. Okay. For the denominator, 7 times 7 is 49. We will have no middle terms. Be negative I times I will be negative I squared, which is really a positive 1. So we'll have this over 50. Factoring a 25 out of the numerator, I would have 1 plus I. And factoring the 25 out of the denominator, I would have it over 2. If I want this in the form a plus bi, that would be 1/2 plus 1/2 times I. For this second problem, where we just have an imaginary part of this complex number, all we have to do is multiply by, let's multiply it by negative I, and so multiply the numerator times negative I also. I'll get negative 5i in the numerator, and for the denominator I'll have a negative I squared. But I squared is negative 1, so that makes this a positive 1, and my solution becomes negative 5i.